All right, guys, we are going to continue with section 10.3, which is solving radical equations. So we're going to be solving equations that deal with square roots and cube roots and all that stuff. So here we go. So in order to solve an equation that has a radical in it, you want to solve it by squaring both sides. Okay? If two expressions are equal, then their squares are also going to be equal. So there's our core concept. So let's take a look at these. Just like when you're solving any equation that we've done so far, you want to try to isolate that x value or that variable that you're dealing with. So we want to get that x by itself. So our first step here is going to be to subtract that 5 from both sides. And now you're going to be left with the square root of x is equal to 13 minus 5 is 8. And now we're going to go ahead and you want to think inverse operation. So hopefully you're thinking to yourself, the opposite or the inverse of a square root is to square both sides. So we're going to take both sides and we're going to square it. When you square both sides, the square root and the square are going to cancel, and you're just going to be left with x is equal to, and then 8 squared is 64, and there's your solution. All right, if we want to take a look at this and we want to say, okay, let me check my work here and plug 64 back into our x value, is the square root of 64 plus 5 equal to 13. Well, the square root of 64 is just 8. 8 plus 5 is 13, so 13 is equal to 13. Let's take a look at our next example. We're going to go ahead and subtract 3 from both sides to start because we want to isolate that x value. Now we have negative root x is equal to negative 3. We have to get rid of that negative sign. So let's divide by, really what we have here is like a negative 1. So we'll divide both sides by negative 1. We'll get the square root of x is equal to positive 3. From this point, to get that x by itself, we've got to square both sides. Cancel on this side. X is equal to 3 squared, which is equal to 9. We plug 9 back in. 3 minus the square root of 9, is that equal to 0? Yes, 3 minus 3 is equal to 0, so we know that it works. Don't get confused on one that's just as simple as number 1. All you have to do right away is just square both sides to get x is equal to 36. Okay? So I think you can go through these on your own. I don't think we need to go through them. They're pretty straightforward, pretty simple equations. Now, let's look at this because there's a lot more happening on this one. Okay? So what we want to do first is we want to start by subtracting the 3 on both sides. We'll deal with this 4 that's in front after that. So this 4 you don't want to deal with first. Just like you're solving any equation, you would start by subtracting the 3, right? If we had something like 4x minus 3 equals 19, you wouldn't divide by 4 first, or plus 3 rather. You would subtract the 3 first to get 4x equals 16, and then you would go from there. Well, same idea here. So now this is going to cancel. Now we have 4 square root of x plus 2 is equal to 16. So you got to think to yourself what operation is happening between the 4 and the square root. Well, that's multiplication. So we're going to divide by 4 on both sides. That'll cancel. Now you have square root of x plus 2 is equal to 4. My square root has been isolated. So now at this point, I could square both sides. I'm not going to subtract that 2 on the inside because that's kind of linked within that square root. So keep it there and square both sides. And now cancels. X plus 2 is equal to 4 squared is 16. And now we can get that x by itself by subtracting 2 on both sides. And you'll get x is equal to positive 14. If we wanted to, we can check that answer, okay, by plugging back in, and we'll see that it ends up working. All right, let's keep going. Now, in example 3, we've got square roots on both sides. So in this case, we've got to square both sides to start. We square both sides, cancels our roots out, and we're just going to be left with 2x minus 1 equals x plus 4. Well, now you're just solving a basic equation with variables on both sides. subtract x, that's going to cancel. 2x minus x is going to be x, so we've got x minus 1 is equal to 4. Add the 1 to both sides, and you'll get x is equal to positive 5. Again, I could check my work, which is going to be important coming up. If I plug that 5 back in, 2 times 5 minus 1, is that equal to the square root of 5 plus 4? You end up getting 10 minus 1, which is 9. So the square root of 9 is equal to square root of 9. So I know it works. Now, in this example, we don't have a square root anymore. We have a cube root. So you should say to yourself, what's the inverse operation of a cube root? Well, the inverse operation of a cube root would be to raise it to the third power, or cube it. So we're not going to square both things here. We're going to cube both sides. Because if I want to get rid of a cube root, I have to raise it to the third power. 5x minus 2 is equal to, get my calculator out, 12 to the third power is equal to 1,728. Go ahead and solve this. Add 2 to both sides. 5x is equal to 1,730. Divide by 5, and x is equal to 346. Okay? So to undo a cube root, aka where your index is there, you must cube both sides. And when we say cube, that means we're raising it to the power of 3. Okay? Let's look at a couple of these. So let's look at number 5. We're going to start by subtracting 7 on both sides. Cancels. We've got x plus 4 is equal to 4. Square both sides. X plus 4 equals 16. And subtract 4, and you'll get x is equal to 12. So you have to be good with your solving of equations here, or else you're going to be in trouble. On one like number 7, we would start by squaring both sides. And then you'd have 3x plus 1 is equal to 4x minus 7. I'm going to subtract the 3x over here, so I end up with a positive x. 1 equals x minus 7. Add the 7, and you'll get 8 is equal to x. All right, if we have a cube root one, we'll just do number 10. If I have a cube root, I've got to cube both sides. That'll cancel this. 3c plus 7 equals 10 cubed, which is 1,000. Subtract the 7, 3c is equal to 993. Divide by 3. And you're going to get c is equal to 331. Let's keep going. We're going to see something interesting here on this one, I think. So how are we going to solve this one? We're going to start by squaring both sides. So now you don't have a number over here. You have an x that we're dealing with on our left side. It's a little bit different than the previous problems that we've seen. So your left side is going to be x squared. And then the roots will cancel here, and you're left with x plus 6. So what do we have here? We have a quadratic that we're going to have to solve. So subtract x. X squared minus x equals 6. to solve a quadratic, I have to set it equal to 0. So now I have x squared minus x minus 6 equals 0. Well, easiest way to solve a quadratic is to factor it. So is there anything that's going to multiply to -6 and add to -1? Hopefully you're thinking -3 times +2. So this can factor to x minus 3 times x plus 2 is equal to 0. Solve this, set it equal to 0, and you're going to get two solutions here. X equals +3 and x equals -2. However, this is where the check comes into play. When we check our work here, all right, if I plug in 3, let's plug in, do the x equals 3 case first. That didn't come out nice. So let's do the x equals 3 case. When I plug in x equals 3, I'm going to get 3 equals the square root of 3 plus 6. So 3 equals the square root of 9. 3 equals 3. We're good to go. When I plug in -2, I'm going to get x -2 equals the square root of -2 plus 6. -2 equals the square root of 4. Now you have to think to yourself, is the square root of 4 equal to -2? Now technically it's equal to 2 or -2. Okay? So you have to remember that. And we're okay here. Let's look at example 6. Subtract 13. Subtract 13. 5n is equal to -10. Let's square both sides. You're going to get 5n is equal to -10 squared is 100. Divide by 5. Divide by 5. N is equal to 100 to 20. Now, this is a case where you have to check your answer. Let's look at 20. Let's plug it in. 13 plus the square root of 5 times 20. Is that equal to 3? 13 plus the square root, 5 times 20 is 100. Is that equal to 3? 13, the square root of 100 is 10. Is that equal to 3? No. So what we have here is we have what's called an extraneous solution. Okay? Because it doesn't end up working. So that's why it's always important to check your answers here. Okay, and what that vocabulary is called is an extraneous solution. All right, we're not going to worry about the word problem here. So that's all you have to worry about today. We go back here, this guy, same thing. Okay, so always look for those extraneous solutions. Good luck. Enjoy. Have a nice day.